We have polluting food, non-polluting food, and clothing, following conventional comparative advantage theory where food and clothing are goods of choice for most. What is polluting food? It is food produced by emitting certain substances into other people's property. Non-polluting food is food where these substances are not produced. Now, we have many heterogeneous individuals in this economy which vary depending on their quality and quantity of the inputs they own. And what this does, it creates a distribution of linear production possibilities for these individuals. Each individual is able to produce all three outputs, but in different proportions. And no one is more productive in non-polluting food than in polluting food, and this is supposed to reflect the fact that it's not easy to be green. It's not easy to be non-polluting, so some resources need to be invested to avoid this. Individuals take prices as given and maximize utility of consumption. So all else equal, this is something about their preferences, all else equal, they prefer consuming non-polluting food over polluting food. Basically, this is a reflection of the assumption that pollution is an undesirable quality in this society. Some process within the Getu model. We have individual production choices and individual consumption choices. Each individual decides between self-sufficiency versus specializing in one of the three goods. Again, each individual decides also whether he or she is going to buy either of the three goods or remain self-sufficient. So this is the individual comparative advantage element here. Every individual needs to determine his or her own comparative advantage in the model. On the market, both kinds of food can be exchanged for clothing. So clothing has some sort of a money attribute. Equilibrium prices determine the specialization and consumption pattern that clears the market. Basically, depending on equilibrium prices, different individuals specialize in different things. And I take this model to 8 scenarios to see the impacts of different institutional systems or different knowledge structure and spatial distribution of pollution. So each scenario has 3 elements. One element is individual knowledge of the food polluting attribute. Individuals may know or not know the polluting attributes. So polluting attributes could be known or unknown. Spatial distribution of pollution could be either global or local. Global is when pollution is distributed evenly everywhere within this society. Legal liability regime could be either absent or present. Legal liability, meaning legal liability for pollution. Are you allowed to emit some substances in other people's property or not? And given these attributes, we can construct 8 different scenarios. So you can just look at the first and see it's a combination of known, global, and absent of the 3. To implement this model, I introduce a spatial distribution of individuals, and I take 24 individuals. Each individual has unique production possibilities and unique and randomly assigned plot of land and natural resources. And this is how it looks, sort of rectangle with 24 rectangles in it. And if you look at the first one, that says 18, we can treat that as a name, individual number 18. I wasn't very creative with names, but these are you can treat those as names. So what this means is every individual has a certain spot here and a unique set of production possibilities. So what these individuals do, I'll show an example of one scenario outcome, and this is a scenario with local pollution, unknown food polluting attribute, and no legal liability for pollution. So one of the eight scenarios. So each of these individuals decides what they're going to produce, what they're going to consume, depending on their production possibilities and preferences, given a certain scenario. So this is what happens in this scenario. So we see that some individuals specialize in clothing, some specialize in polluting food, and some specialize in non-polluting food. And these arrows show the direction of pollution emissions, and which are local in this case. So now I would like to show an impact of changing the legal liability structure in this scenario. So this scenario is without legal liability. It's the same. This is the same diagram as we saw in the previous slide. So when we introduce legal liability for pollution, what happens is that now people are not allowed to produce polluting food anymore. So they need to switch either to clothing or non-polluting food, whatever they prefer. And you can see that some people switched, like individual 6, switched to non-polluting foods, but individual 4 switched to clothing. So there are differences in their responses to this change. And also, if we focus, say, on this area in the center of our society, we can see that half of the producers previously produced polluting food, and half of them produced clothing. Now, if you look at the same area after, we see all of them produce clothing. So no food production in this area anymore. But if you look at the surrounding area, we see that there's plenty of food producers around. So we see that there's differential effects of the same standard across the geographical area. So then I went and wanted to apply this result to the situation in the Canadian dairy industry and to our county level data. So the motivation for this is that in the early 90s, mid-90s, there was a number of new agricultural environmental regulations that were introduced throughout Canada. And so we wanted to see whether these new standards might have contributed to some of the spatial changes in the allocation of dairy production within provinces. And one of the things that I wanted to investigate here is whether this effect was differential depending on the initial, say, pollution intensity or production intensity in different areas. So what I ended up doing is to explain or estimate a statistical regression where we try to explain 1996 to 2006 change in per kilometer number of dairy cows using county data from Statistics Canada. So first to present some of the general statistics for you to get some idea of what was happening in this period. We have 1996 dairy cow population density in cows per kilometer squared. We see there's about 2.7 animals per square kilometer. Now the change between 96 and 2006, 0.5. So compared to the average, it's fairly significant. And it's a decrease, 0.5 per square kilometer. Now human population density, about 47 people per square kilometer. An increase in the 10-year period of 6 persons per square kilometer. Some of the general trends that I wanted to look at, general economic trends, change in cash crop area to capture general trend in the agricultural production. So increase in cash crop area in the order of 43%. Change in cash receipts, this is percentage again, per county level, 37.3%. And we have change in average person income, just to capture some of the general economic conditions, 8,377 nominal dollars. So what I was interested in to explain variation in this statistic, variation across counties. So these are some of the results of ordinary least squares regression, where I'm using 1996 to 2006 change in the area population density as a dependent variable, and then we have some provincial dummy variables. Western provinces, Ontario, Quebec, and Atlantic provinces are excluded. We see there are some differences, some statistically significant. Three stars mean at 1% level, and 2 stars at 5%, and 1 star at 10% level. But what I was particularly interested was what was the effect of human population density and cow population density, the initial in 96. So we see negative effects. So what this means is that counties with higher human and cow population densities tended to have higher decreases or lower increases in the area cow population in the 10-year period. Now, to make sure that I'm not capturing something else, I controlled for changes in farm cash receipts and changes in per person income. This variable was supposed to see whether this changes in dairy population was just riding away or following a trend in the general agricultural activity. And yes, it was. We see that the correlation is positive, statistically significant, but it still wasn't enough to overturn the significance of the two coefficients. And similar with changing per person income. Now, from this we can see that both the model, the theoretical model, and there's some empirical evidence that these initial environmental pressures had an effect, and a negative effect, on the change, or the spatial change in the allocation of production. Now, to go back to the other two research questions that we had, basically we wanted to see how we can observe changes in comparative advantage across provinces and how we can implement these changes in provincial quota allocations. And I came up with two options. I won't go into detail into theoretical justification of these options, which are presented in Chapter 5, but I'm happy to discuss it later. Option A is allocation through a national quota market or auction. What this would mean is that the Central Supply Management Agency, Milk Supply Management Committee, or CVC, could take this over-base quota, so additional increase in the national production, and give it to a national auction. So farmers from all provinces could bid for this quota, and then the distribution would be determined by the bidding process. But I have some suspicions that this wouldn't be easily politically implemented. So there's an option B, and this option is actually closer to solving the initial economic problem identified in the law, where it asks how does Canadian Milk Supply Management Committee allocate quota. Option B involves translating provincial quota prices into provincial over-base quota shares. And I provide within this option two alternative allocation methods between which the agency can choose whichever they prefer. In both of them, I follow a proportionality principle, which is higher provincial quota prices lead to higher provincial quota share relative to others. And I also account for the effect of differences in provincial supply management policies on quota prices there are two elements that account for milk price differences and quota price ceilings that are imposed